All right, division by 1 is so great. It's so awesome. I wish we could do it all the time, actually. Because when you divide anything by 1, take a number, divide by 1, it's itself. Anything divided by 1 is itself. Now, we're showing letters here, right? But down here, we're showing examples. 5 divided by 1 is 5. Or 7 divided by 1 is 7. Which is why it's A divided by 1 is A, because it's the same letter. Which means it'd be the same number wherever you have the 8. And it doesn't matter if you use decimals, fractions, negatives. No matter how jacked up the number may look, if you divide it by 1, it's still going to look just the same. It's the same value. Now, this property becomes pretty crucial later on. But just understand, it's kind of like multiplying by 1. If you multiply something by 1, you get the same thing back. Well, if you take something and divide it by 1, it's the same thing. But this does not work backwards. You would not say, well, 1 divided by something is the same thing. No, it's only when 1 is the divisor that this works. So division with base 10s. So the way this works is what we're going to do is identify any zeros farthest to the right of both the dividend, that's this top number, and the divisor, that's the bottom number, at least when it's written like this. And some of you know that that's a numerator and denominator. I'm going to try to steer away from those two vocabulary words because we're not really working on fractions yet. Okay, so I would look at these two numbers, and I would say, look, we got a 0 in the top number, which is the divisor, the dividend, and a 0 in the bottom number, which is the divisor. That one's the divisor. And what happens is they cancel each other out. Now, when we say cancel, what really happens is these become what we call a phantom 1. So if you cross them out like this, that's really a 1, which also makes these values a phantom 1, which also means that you don't actually have to write them in. Now, this changes it into 300 divided by 50, which could be further simplified because you now have a 0 in the top number, the dividend, and a 0 in the bottom number, the divisor, which will then cancel each other out. So once again, I'm actually going to get rid of them completely. So this is what we end up with now. This is 30 divided by 5, and that's one of our facts that we should have memorized, right? 30 divided by 5 equals something, and using the fact family, you'd say, well, 5 times something, almost wrote the answer there, 5 times something is 30, right? And once we get our multiplication facts memorized, you'd know 5 times 6 is 30, so 30 divided by 5 is 6. And that would be the answer there. So that's what we're gonna do with these problems, and we even see a divide by 1 thing, which is pretty nice. So whether you cross these out or whether you actually erase them is really up to you. For this one, I'll cross these out because it's a very common technique that's used. And so I see, okay, I got 6,000 divided by 50. The 6,000 dividend has a 0 farthest to the right. And the 50, the divisor, has a 0 farthest to the right as well. So I could say, you know what, I'm going to cancel those out, which now makes this 600 divided by 50. I'm sorry, 5. There we go. Now, when your dividend still has zeros attached to it, you can kind of focus on the divisor and figure out, well, maybe a smaller value within 600 that 5 goes into. A little bit easier, right? Because otherwise you're looking at, well, how many 5s is there in 600? There's a bunch of them, right? And that number is quite large, but if we look at it this way, we can say, you know, I got a 0 here, and if I attach that to the answer because it's part of the dividend, then I can look at this as 60. And you may think, well, why are you using 60? It's because 5 goes into 60 evenly. If you go back to the table, you'll see that 5 goes into 60 12 times. Or, using the fact family, it'd be 5 times something equals 60, and that something is 12. So from the 60 divided by 5, you get 12. And then we just tack on this 0 here that we didn't use as part of the answer. So really, 600 divided by 5 is 120 because we had that 0 that we tacked on to the end. Or really, if you went back to the beginning, 6,000 divided by 50 is also 120. So this next one will work the same way. I'm going to cross these out a little bit differently though. So I have a 0 on the top, a 0 on the bottom, they cross out. And I have another 0 to match a 0 in the bottom from the top. Now I put 2 slashes through the second one in green just to show that it's a different 0 that was crossing that one out. But they still match, right? So what this ends up being then is, looks like 710,000. 1, 2, 3, 4. Yeah, I got that right. And we're really dividing this by 1. Well, the nice thing about dividing by 1, whether you use the 0 thing like we did in that last example, right? You could say, well, the quotient is going to have 4 zeros, just like that last one did with the 1 0. And then you take 71 divided by 1. Well, it's the same thing. Anything divided by 1 is itself. So 71 divided by 1 is 71. So I tack the 71 onto those zeros, and it still makes 710,000. See how that's divided by 1? It gives us the same thing back. So our final quotient here is 710,000. So we'll do the same thing on this one. So I'm going to match the zeros, right? I got this 0 here, matched with this one. And then we got the second 0 to match with this one, which then changes this problem to 240 divided by 12. Well, I'm going to take the 0 from our dividend and just tack it onto the answer over here and pretty much forget about it. And that changes this problem then to 24 divided by 12, which gives us the fact family of 12 times something equals 24. Well, 12 times something equals 24. Whether you use the table or not, you'll still get the same answer. That's a 2 right there. 12 times 2 is 24. And so I tack the 2 onto the red 0 above, and that becomes our quotient, 20. The division is generally where we run into most of our problems because not only is multiplication very different, but division is kind of backwards multiplication. So if we struggle with multiplication, generally we doubly struggle with division on this stuff, okay? But I don't want you guys to struggle, so if you do, please ask your questions, all right?